Let's go over this starter problem. And those of you that are absent that might be doing this online, just pause the video after I've done going over it, and then try to work it yourself and then watch the solution. So anyway, we've got two different circuits here. Here we have a series circuit, and you can tell that the resistors are in series because there's only one conducting path that goes through them. So these two resistors are in series. And then number two, I've got the same two resistors and the same voltage source, but now they are in parallel. And so what we want to do for these two circuits is find out this stuff. What is the total resistance of this circuit? What's the current through the circuit? And what's the voltage drop across the first resistor? And what's the voltage drop across the second resistor? And then, so let's do that first, and then we'll go over number two. So the total resistance, if you've got resistors in series, you just add the resistance. So it's just this one plus this one equals R1 plus R2. So that's 4 ohms plus 2 ohms. Now you're going to take a quiz here in just a minute. I want you to show your work the way I'm showing it. Okay? Don't just do it in your head and write the answer. I want you to write down how to get to that answer, okay? Because I can't read your mind. I can only read what you put down on paper. And I give partial credit. So if you don't show me how you're getting it, then you're not going to get that partial credit. So the total resistance is 6 ohms. Now the total current, I would use Ohm's law because I know the total voltage and now the total resistance. And Ohm's law is this. E, or actually, I used V right here because on the quiz it's listed as V, but it's the same thing as E. E equals IR. So I is equal to total voltage divided by the total resistance. And so this total voltage that I've got in the circuit is 12 volts divided by 6 ohms. So notice I wrote down the formula. I wrote down Ohm's law. I want you to do that and not do it in your head. Although I think on the quiz you may need a calculator because the resistances are not this easy. And so that would be, well, 12 volts divided by 6 ohms is 2 what? Amps. So that one's done. Now, see, the total current is 2 amps, but that 2 amps goes through this resistor and it goes through this resistor. So the voltage drop across the first resistor is equal to IR, the current times the resistance. So that's 2 amps times 4 ohms. And remember, an ohm is just a volt per amp, so the amps would cancel, and you're left with 2 times 4 is 8 volts. And V2 is equal to I2 R2, but I2 is just the current. It's the current through the second resistor is just the total current because there's only one branch. So that's going to be 2 amps and times 2 ohms, and that's going to be equal to 4 volts. Now look, notice what these two voltages add up to. An 8-volt drop and a 4-volt drop is a 12-volt drop, and we need a 12-volt drop, right? Because we went up in 12 volts, so to get back down to where you started, you have to release that much energy per unit charge. So in other words, when current is flowing in this circuit, the battery is putting 12 joules of energy per coulomb of charge. That's what a volt is, into the electricity. So this takes some of the energy out, and this takes some of the energy out. If these are light bulbs, they're giving off light and heat. If they're just plain old resistors, they just give off heat. Might be a motor that's doing work and turning a propeller or something, but they take the energy out of the electricity when current flows through them and disperse that energy into the environment somehow. So here are my two answers for the voltage across 1 and the voltage across 2. So that's how you do number 1. So again, you add up the resistors. If they're in series like this, you just add them up and then use Ohm's law for the rest of it. Okay? Any questions on that first one? Okay, the second one, here we've got resistors in parallel. So everything up here is 12 volts. Everything down here is 0. So when you go from here to here, you have to jump down 12 volts. And you have to jump down 12 volts. So let me put solve right here. So you can just see V1, that is the voltage drop for this resistor, is just 12 volts. V2, that is the voltage drop for this guy, is this again the same voltage drop, 12 volts. Now we were calling this E before, but on the quiz it's called V, and it's quite common to use either one of them. Okay, sorry. Q. It's quite common to call it E or V, and it depends on what book you're reading. It depends on who your teacher is. It's annoying, but it's the way it is. The world is annoying, believe me. It just gets more annoying as you get older. All right, so now we know what these voltage drops are. We can figure out what the current is by using Ohm's law. The voltage drop across this resistor is equal to the current through the resistor times its resistance. Well, we're trying to find the current, so I equals V over R. So that we know the voltage drop from here to here is 12 volts. The resistance is 4 ohms. 12 divided by 4 is 3. So we can say that I1 equals 3 amps. Okay, is that what you got? Okay. Now for this second one right here, again, so V2 equals I2 R2. So I2 is just equal to V2 over R2. That is a voltage drop divided by the resistance will give me how much current is flowing in here. So that's 12 volts. Again, same voltage. Remember that resistors in parallel have the same voltage drop, but they share the current. And this one's going to, how much current is this going to have? Well, 12 divided by 2 is 6. Six amps, right? Okay. Now, if this has, now by the way, look at which one has the most current running through it. The low resistance one. Remember, resistance says, hey, here's how many, you know, this is how many volts you need to get 1 amp of current to flow through me. So this says, hey, you need 2 volts to get 1 amp of current. Well, I don't have 2 volts, I got 12 volts. That's why you get 6 amps. And so if this is 6 amps through here, and this is 3 amps through here, how much current is coming into that junction right there? Well, to get the total current, you just add. See that the 2 resistors have to share the current. So most of the current goes through the lowest resistance, but there is some current that goes through that bigger resistor. So that's going to be 3 amps plus 6 amps. That equals 9 amps. That's the total. That's the total current through that's being delivered to the circuit, the current that's up in here. Now, what's the total resistance of the whole thing? Well, we know that E equals IR, or V equals IR, whichever you prefer. And then, so R is equal to E over I. But now this is just 12 volts. That's the total voltage. And I know that there's a total of 9 amps. So the total resistance of this guy is, well, what's 12 divided by 9? 1. And then there's 3 left over, and 3/9 is 1/3, so 1.33 ohms. And one thing to notice, let me zoom all the way out if I can. I guess I am zoomed out. Let me pull this up. So, in this circuit where they're in series, you just have one loop. So the current is the same for both resistors. They have the same current. But they have to split up the voltage because this delivers 12 volts. So from here to here it has to be down 12 volts. And it happens to be 8 volts, then 4 volts. To give a total of 12 volts from here down to here. To figure out the total resistance, you just add them. Then you can figure out the total current, which is the same as the current through each resistor. And you can use Ohm's law to figure out what the voltage drop is. If they're in parallel, well, look, they have the same voltage drop from here to here, from 12 down to 0. It's a 12-volt drop. But look right here. See, the current comes in, but it gets split up into 2 currents. And you can use Ohm's law to figure out how much current goes through here and how much current goes through here. And then you can add those currents together to get the total current of the circuit. And if you know the total current and you know what the voltage is for the circuit, you can figure out, use Ohm's law to figure out the total resistance. Okay? Does that make sense to you? Well, I hope so. Okay. That's all.